A hydraulic accumulator quotation can appear complete and still leave the critical engineering decisions unresolved. A nominal vessel size, shell material, and price do not establish whether the unit will deliver the required oil volume, fit the pressure window, tolerate the fluid and temperature, connect to the machine, or satisfy the required certification scope. When suppliers fill those gaps with different assumptions, their quotations are not technically comparable. A reliable RFQ begins with the accumulator's primary function. Energy storage, emergency movement, peak flow assistance, leakage compensation, pulsation damping, and shock absorption require different selection methods. If the unit serves several purposes, identify one as the sizing basis. Then describe the operating sequence. How it charges, how long it remains charged, what triggers discharge, where the flow goes, how quickly it must be delivered, and how the system resets. Success must also be observable. It may mean completing a cylinder stroke, holding pressure for a defined period, reducing measured pump ripple, or absorbing a specified transient. This acceptance event prevents the supplier from guessing the required performance or safety margin. Pressure data must distinguish normal operating pressure, maximum charging pressure, and minimum functional pressure. Include units and measurement locations. Relief settings, expected surge magnitude and duration, proof or test requirements, and any specified design code belong in separate fields. Cycle frequency, machine life, standby periods, and repeated rapid charging should also be declared. Where available, a pressure trace helps separate occasional peaks from regular fatigue and thermal duty. Pre-charge requires more than a percentage. State the requested value or require the supplier to calculate and declare it. The quotation should identify the gas, tolerance, reference temperature, and delivery condition. It must also define whether the accumulator arrives pre-charged, partially charged, or uncharged, and who is responsible for final setting and verification. A ratio copied from another machine may reduce oil acceptance or permit damaging bladder movement if the duty, temperature, or pressure window differs. Usable fluid volume is the central sizing requirement. Specify the oil volume required between the defined upper and lower pressure states, together with discharge time, repetition rate, and the event being supported. Require the supplier to disclose the calculation method, thermal or gas law assumption, starting temperature, leakage allowance, and pressure definitions. Recharge flow, available pump capacity, time between events, and long standby periods must also be considered. A large accumulator may deliver enough oil yet recharge too slowly for the machine cycle. Fluid information should include the exact hydraulic medium, viscosity grade, additives, and any water-based, biodegradable, or fire-resistant formulation. Minimum startup temperature, normal fluid temperature, maximum transient temperature, ambient range, and storage conditions should be separated. Bladder and seal materials are application choices, not universal answers. Compatibility should be confirmed against the actual chemistry, temperature, and exposure. Connection data must define the thread or flange standard, size, sealing method, orientation, and mating interface. Include mounting position, available height and diameter, brackets, vibration, lifting constraints, gas valve access, and service clearance. Isolation blocks, safety valves, gauges, adapters, clamps, and charging equipment should be reviewed as part of the complete assembly. Evaluate evidence in 3 tiers: pass, conditional, or fail. Model drawings, sizing calculations, material compatibility, pressure test scope, certification applicability, and traceability must be linked to the quoted model. A conditional item needs an owner and due date. A generic certificate or unsupported nominal capacity cannot justify technical release. Before comparing price or lead time, normalize every proposal to the same function, pressure window, pre-charge reference, usable volume, temperature assumptions, materials, ports, accessories, and compliance route. Then freeze the approved model, drawing revision, settings, documentation package, and change control requirements. That discipline turns a commercial quotation into a defensible engineering decision.